Welcome to the second summer assignment tutorial on metric units. And here I've drawn a chart on metric prefixes. This is right out of your textbook in chapter 1. And really, if you apply yourself here, you should be able to recreate this chart from memory, from giga all the way down to femto. And so here we're going from the largest down to the smallest prefix, and we're using scientific notation to indicate the relative size of these prefixes. So giga is 10 to the ninth, or a billion times greater than the standard unit. So let's say that standard unit would be the meter, which is a unit of length. Then a gigometer would be 10 to the ninth, or a billion meters. Whereas a megameter would be 10 to the sixth, or a million meters. And a kilometer would be 10 to the third, or 1,000 meters. Whereas a decimeter, here we go now to smaller than 1. So we're going down to fractions, 10 to the minus 1, or a tenth of a meter, and on downward here. So if I draw a little dotted line, here we're separating units that are now bigger than 1 from units that are smaller than 1. Okay, so some real common ones, if we look at kilo, 1 kilometer is 10 to the third, or 1,000 meters. Okay, if we look at centi, let's say I say 1 centiliter, and I use liters now as my basic unit of measurement, would be 10 to the minus second liters. Or 1 microgram would be 10 to the minus 6 grams, or a millionth of a gram. Now, micro, this symbol here, let me circle this in green. It sort of looks like a cursive U. This is the Greek letter mu. It's pronounced mu, and that's what it looks like in Greek. So when I say mu, I'm really referring to the symbol for micro here. Okay. 1 picometer, or sometimes it's pronounced pico, is 10 to the minus 12 meters, or a trillionth of a meter. So now we're getting into the really small here. And by the way, if we're talking about sizes of atoms, we're talking about nanometers and picometers. Okay. If we want to talk about distances in the universe, gigometers would probably be a more appropriate unit of measurement. We want to talk about something that's really big. So we're talking about planets and suns and galaxies and so forth. But then we get down to atoms. We want to go down here to the smallest units. Now, this is a good time to introduce conversion factors when we're working with these units of measurement. Okay, and conversion factors are going to be your friend almost all throughout our chemistry course. So conversion factors are exactly what they say they're for. They're used to convert from one unit of measurement to another. So let's use a couple simple examples here. Let's say I have 6.5 times 10 to the minus 6 meters, and I want to know what this is in micrometers. Well, I can use a conversion factor in order to do that. And my conversion factor, a conversion factor, is written as a fraction. And I'm going to show it in blue here. Okay. And in the numerator of the conversion factor, we always write the units we want to convert to. So in this case, I want to convert to micrometers. Some people pronounce it micrometers. And the denominator of the conversion factor is the unit we're converting from. It's the unit we want to cancel out. So in this case, it's meters. So let me label this too. So the numerator is the unit we're converting to. If you remember this, you can write any conversion factor you need, and you can solve almost any problem you want. And the denominator is the unit we're converting from. So just for a minute here, let me go back to black and make sure I put my equal sign in there. Now the numbers that go in here are going to be standard. You know, they're going to apply to these prefixes here. And so in this case, we know that 1 micrometer is equal to 1 times 10 to the minus 6 meters. And I'm getting that really from this part of my chart over here. So I've written my conversion factor, and all I need to do here is do the math. So this ends up being a division problem. Because I'm multiplying by 1 over something, that's the same as dividing. So I have 6.5 times 10 to the minus 6 divided by 1 times 10 to the minus 6. So my 10 to the minus 6's cancel out, and I end up with 6.5 micrometers. We'll do another simple conversion factor problem. Let's say I have 2.5 times 10 to the minus third liters, and I want to convert into milliliters. So I want my answer to be in milliliters. And sometimes milliliters is written little m with a big L, or it can be written as little m, little l. Either way is fine, it doesn't matter. I've seen it in both ways are appropriate. So now I want to use my conversion factor. I'll put that in blue just to emphasize it. Remember that my numerator are the units I'm converting to, so this would be milliliters, and the denominator are the units I want to cancel out, so that would be liters. Okay, and I know from my chart I need milli. All right, so 1 milliliter is 1 times 10 to the minus third liters. So my problem becomes 2.5 times 10 to the minus third divided by 1 times 10 to the minus third. So the 10 to the minus thirds cancel out, and I end up with 2.5 milliliters. We'll try another one where we have 2 conversion factors really are needed. So if I have 12.5 times 10 to the minus 8 kilograms, and what I want to do here is I want to end up with milligrams. Okay, I'm going to have to squeeze this guy in because I didn't allow myself a whole lot of space. And I want to go from kilograms to milligrams. So before I do anything, what you really should do in this type of problem is think to yourself, or any conversion factor really is, think, okay, what are the steps that I'm going to need to take to go from one unit to the other? So here I have kilograms. It's probably easiest to go from kilograms to grams, and then once I'm in grams, then I can go to milligrams. So this is a 2-step problem. So my first conversion factor, I'm converting to grams. So grams are going to go in my numerator, kilograms are going to go in my denominator. And I know from my chart over here, so if I look at kilo, okay, this is where I'm going here. There's 1 times 10 to the third grams in 1 kilogram. So there's my first conversion factor. My second conversion factor involves going from grams to milligrams. So milligrams goes in the top, grams goes in the bottom. Numerator, denominator. Unit I'm converting to, unit I want to cancel out. Okay? And I look at milli. Milli is 10 to the minus third. All right? And for every 1 milligram, that's equal to 10 to the minus third grams. Okay, so now I have my problem set up, and this becomes 12.5 times 10 to the minus 8 times 1 times 10 to the third, really then divided by 1 times 10 to the minus third. When I do my math, I end up with 0.125. Should have put that in black. Let's just do that to keep everything the same. 0.125 milligrams. So this is a 2-step conversion factor. Okay? And we will see many, many more of these. So this is just your first introduction to conversion factors. But let's do another, just for some fun. And this one's going to be a little trickier. We're going to put it across here because I want to leave myself a lot of room. And what I want to do here is I want to convert 4.23 millimeters cubed. Okay, I want to convert that into microliters. Okay, there's my Greek letter mu, microliters. So I have a cube there. So what this means is millimeters cubed is a unit of volume. And we know that liters is a unit of volume, so microliters is a unit of volume. So I have to find out what pathway am I going to take to go from millimeters cubed to microliters. Okay. Well, there's one, when we're talking about volume in the metric system, one thing to remember for volume in the metric system, this is going to be really helpful if you always remember this, is that 1 centimeter cubed of volume is always equal to 1 milliliter. Remember that. They are the same. Okay, we can prove that in class. It's real simple to do. So then that can help us determine our pathway. You know, what units are we going to go to? If I can go from millimeters cubed to centimeters cubed. Okay, once I'm in centimeters cubed, then I can go into milliliters really easily because I know this conversion right there. Once I'm in milliliters, I can go to liters. And then once I'm in liters, it's going to be super easy to go to microliters. So there's my path. So what this means is that I need 1, 2, 3 conversion factors in this problem. My first conversion factor is going to take us from millimeters cubed to centimeters cubed. And this one is going to be a little interesting. All right. Let me set up my problem here, or let me set up my fraction. And I know regularly that there's 10 to the minus first centimeters in 1 millimeter. Okay, that there is a tenth of a centimeter in a millimeter, but we need this to be volume. So I can take my conversion factor that's in length and I can make it a volume conversion factor. How do I do that? I cube everything. So what I do is I have to cube the number. 10 to the minus first, I'm going to cube that, and I'm going to cube the unit. So I have 10 to the minus first cubed centimeters cubed. All right? And I have to, same here on the bottom. This is 1 cubed millimeters cubed. So what I've done here is I've converted regular length units into volume units by cubing the units, but I also have to cube the numbers as well. Okay, so we have to cube both number and unit when I do that. Now that I've done that, my conversion factor to milliliters is easy. Remember, milliliters goes on the top, centimeters cubed goes on the bottom. There is 1 milliliter in 1 centimeter cubed. That's the thing I told you to remember down here, that fact. That'll help you all throughout the year. Now I'm in milliliters, I can go to liters. So liters goes on the top, and I need milliliters to cancel out. There's 1 times 10 to the minus third liters in 1 milliliter. Then I can go to microliters, my last conversion factor that I need. So microliters goes on the top, liters goes on the bottom. There are 1 times 10 to the minus 6 microliters in 1, or I'm sorry, there are 1 times 10 to the minus 6 liters in a microliter. If you don't remember that, look back up here at micro. That's equal to 1 times 10 to the minus 6, whatever our main unit is. So 1 times 10 to the minus 6 liters in 1 microliter. I do my math, Okay, so I have 4.23 times 10 to the minus first cubed. Okay, and you can figure out what that is. I'm then multiplying just by 1, and then that times 1 times 10 to the minus third, and then I'm dividing by 1 times 10 to the minus 6. Okay, and we end up with 4.23 microliters. So this is a case where we actually have 4 conversion factors that we need here. Okay, and remember that in this first conversion factor, I'm working in volume, so I used my length conversion. I converted it to a volume conversion by cubing everything. I cubed the number value as well as the unit value.